Hi, in this video I'm going to show you how to compute the forecast error measurements using Excel. And to do that, I'm going to use this problem 8 from page 34 of our class notes demand forecasting. In this problem we have different years, 6 years, and the demand for each one of these years. And I'm going to reproduce these numbers in Excel like in here. And the problem on page 34 says, calculate the forecast for year 7 using a 3-period simple moving average. So I want to forecast year 7. So year 7 is going to be equal to simple moving average. So it's the average of the 3 previous years. Okay, that's the forecast. And then we answered this question. And if you take a look at page 34 in the solution, the forecast is 8,656 units. The same thing we have here, but here we have the decimal points. The table in the book or in the class notes doesn't have it. Okay. So the next question is, what is the mean absolute deviation for years 4, 5, and 6 using this model? When the question says using this model is the 3-period simple moving average. Okay, so I want to compute the mean absolute deviation. If you take a look, the mean absolute deviation is the sum of the errors, the sum of absolute errors divided by the number of periods. Okay, so I have to compute the errors. Okay, the error is the difference between the demand. The difference between the demand and the forecast. But I don't have the forecast for years 4, 5, and 6. So I have to compute it in order to get the error. So how I can compute the forecast? Which model to use? The question says using the same model that we use to forecast year 7. We use a three-year moving average. Okay, let's do this. So the simple moving average using 3 periods for year 4 is equal to the average of years 1, 2, and 3. Okay, and the same thing for years 5 and 6. Okay, I go here just to make sure that year 6 is the forecast is the average of the 3 previous years. That's okay. Now I can compute the error. The error is simply the demand minus the forecast. Again, the demand minus the forecast. One more time, the error is the demand minus the forecast. Okay, so I have the errors. Now let's take the error square, because some of our measurement errors need the error square. So the error square is simply the error taken to the square. You can compute the square like this in Excel, or you can multiply the error by itself. So again, the error multiplied by itself. Okay, I simply multiply the error by itself. Now I can compute the deviation. The deviation is part of the absolute deviation, one of the measurement errors we have. So the deviation is simply the difference between how much the demand is and how much our forecast is. So the deviation is how much our forecast deviates from the demand, which is the same thing as error. Okay, you can see that if I compute how much our forecast deviates, what's the difference between demand and our forecast, is the same thing as error. Okay, but I'm doing both. They're the same thing, but I'm doing both so you can understand. I want to stress out that the error and the deviation are the same thing. It's just different terms. Okay, but this deviation, we can take the absolute deviation. Absolute deviation, which is simply the deviation in absolute terms. So to do that in Excel, we type equal ABS, and we select the number we want to get the absolute value. So now I have the absolute deviations. Now I'm ready to compute my measurement errors. Let's type here, not in year 7, because these are errors are not about the year 7. But let me put it here. Measurement errors. So let's call the mean error for the forecast in years 4, 5, and 6 using the 3-period simple moving average. The mean error is simply the average equal average, mean is equal to average, and then I type average and select the 3 years, the 3 years that I have this error that I want to compute. So this is my mean error for years, for forecasting years 4, 5, and 6. Now I can take the mean square error, which is our second measurement error, which is simply the average of the error square for the forecast of years 4, 5, and 6. Now I can take the mean absolute deviation. The mean absolute deviation again is equal to the average of the absolute deviation in our forecast for years 4, 5, and 6. You see that when we do this, we compute these errors and deviations. It's very clear for us what they mean, and then it becomes easy to compute the measurement errors. Now we have the mean absolute percent of error, okay, percent error. And this is equal to the mean absolute deviation divided by the average demand for the periods under consideration. So we select the mean absolute deviation and divide by the average of the demand for years 4, 5, and 6. Okay, and then becomes this is a percent. Okay, as a percent number, 0.14 or 14% of absolute error. And finally, we have the tracking signal. The tracking signal is going to be equal to the sum of our errors. So I type equal sum, open parentheses, and then I select the errors for years 4, 5, and 6, and divide by the mean absolute deviation. And this is -3. So the tracking signal is a cumulative deviation of our forecast. And if you take a look here, the forecast is always higher than what the demand is, which causes our error to be negative. And we see that this 3 is reflected here as deviations from what the demand is. So we're always predicting more than what the demand is. So this is how you compute these measurement errors. And if you take a look, we can answer the question in the class note problem, what is the mean absolute deviation for years 4, 5, and 6? Is 1238.89. In the class note, we have 1239. Okay, so it's the same answer. And also, on top of that, I'm answering all other possible questions using measurement errors. Okay.